Okay.
All right.
Hi.
And then you're
One more time.
you're listening to
Keyboard and Quill.
From StarTree, creators of the Real-Time Analytics Summit.
And
podcast.
Hi, I'm Tim Berglund.
I'm Rachel Pedreschi.
In this episode, we're going to explore Apache Kafka, the invisible technology powering apps millions of people use every day, like LinkedIn, Uber, and DoorDash.
Welcome back, intrepid history explorers. Last time we left you around 2010, and the internet is officially a thing. About 68% of US homes had broadband internet. So the days of dialing up to go online are ending, but online still means probably sitting down in front of some type of computer.
Yeah, it's a thing that you do. There's like some session. You do it and not some other thing.
Smartphones are really starting to take off. The iPhone was introduced in 2008. By 2010, they actually have at least a 30% penetration in the US.
Smartphones overall. That's a lot.
Yeah, it is. And more people have this always connected internet terminal in their pocket. Instant messaging, credit card fraud, notifications, and texting are becoming more and more normal.
Yeah, that kind of thing is, the stage is definitely set.
And do you remember the phrase, there's an app for that, with the old iPhone 3G commercial in 2009?
That is commonplace. It's
pretty
just,
commonplace.
You do stuff, you install apps.
So let's think back to our very first episode. If you've been traveling along with us, we started this series by talking about the quickening pace of life and mentioning that hieroglyphics were around for about 5,000 years. But by 2010, life is extraordinarily fast. Now, of course, as we're sitting here in 2024, we don't have the luxury of millennia to look back at to see how much faster things have got. Maybe this was going to seem ridiculously slow. But from where we sit right now, Tim, things go by pretty quick.
They seem to. And whether it's in 2024 or back in 2010, it seems like things move along at a pretty good clip.
Right. And telecommunications, these smartphones that are so ubiquitous, even by 2010, are a result of centuries of changes in telecommunications.
And the stage is set for things like Uber and Lyft, ride sharing to come along, meal delivery. These aren't quite there yet in 2010, but all the pieces are in place and those things are about to happen.
One thing that we haven't really touched on is social media. This was another really important cultural transition that was starting at this time.
One that I think, even from where we sit in this studio now, we don't fully understand what the impact of that has been. You know, by 2010, MySpace had sort of taken over the world and then gone away, seemingly, and Twitter and Facebook were imposing themselves on...
What about Friendster?
Friendster was gonester by 2010. But these were changing the way we communicate and relate, again, in ways that I don't think you and I fully understand right now.
And a whole lot faster than sending a pen pal letter across the seas.
Yeah, that's the thing. That's contributing to this faster pace of life. It can be hard to untangle all these factors, but we are starting to bring some threads together now. When Uber shows up and that little car moves around on my screen, how does that work? How does my phone know where that car is? There's a lot of data moving around there. And how does data move around these days? And I don't mean the radio sense of the cellular network and all that. We talked about that when we talked about telecom. But how does data move and where did that technology come from?
So we're going to set up a little bit of a behind-the-scenes look. Throughout our stories that we've been telling, we have had the luxury of being able to look back and tell the story from a perspective of being in the future. So we understood what was important and what drove innovation across the centuries. But a lot of times, the people that were living in those times didn't know about it. They didn't necessarily know that cuneiform was what influenced hieroglyphics, for example.
It's difficult to know in the moment that these things are happening and what their impact will be.
Or really how a telegraph worked. They knew that it did, probably didn't understand all the intricacies or how it ended up getting there.
Absolutely not. And most people don't. I think what you're getting at, Rachel, is what we're talking about today, something that's very much behind the scenes.
Right. It's invisible technology to most of us that make these amazing technological advances come together.
So, Jeff, if you haven't moved us back to 2010 in the time machine yet, we need to go there now.
Let's do it.
To Sunnyvale, California. And that might be a little less exciting, but let's go there. Okay, y'all know what LinkedIn is, and we're at the offices of LinkedIn in about 2010. This is the professional social network. Back then, Rachel, do you remember LinkedIn? I mean, it's hard to put years on it, but it was kind of like resume and Rolodex, right? You had some contacts, and maybe you didn't really keep your contacts in there, but you sort of did, and your basic CV, and you didn't go there a lot, right?
No, I went there when I needed a job.
Right. Hard to make a living as a social network if that's your engagement model, because Twitter and Facebook were showing the world what engagement and addiction really were like.
Right.
They kept you coming back, and I think there was some pressure there. So again, in this world of 2010, looks a lot like our world now. Some things are a little different. If you're a person who develops technology, say you're a software developer, the world is about to change a lot. And we're going to tell you that story. Now, we got to talk to Jay Kreps. He's the co-founder and CEO of a company called Confluent and the co-creator of this largely invisible technology called Apache Kafka. Now, I want you to take our word for it. You don't get through a day using websites, using apps, doing whatever it is you do, mediating your commercial and social life electronically as you do, without there being this thing, this Kafka thing running in the background. There's kind of a cool story here about what was going on and how it came to be. Let's listen to Jay on that.
The context at LinkedIn was it had come to life originally as sort of a flat resume site where you could post information about where you worked. And the kind of evolution it needed to go through was twofold. One was getting a little bit richer and more sophisticated, taking on some of the live features of a social network, like what's happening in your professional network, what are the updates, what's relevant to you, what's news or articles that you need to be aware of, who are people you should connect to, all that kind of stuff. So getting smarter, and then at the same time, kind of getting bigger. Early on, it was a site with 10 million users. And then, of course, that grew. And social networks are always tricky when they grow because you got all the additional people, but all their kind of interrelations are, in some sense, grow faster than the number of people, right? There's more relationships than there are humans. So the challenge at LinkedIn was, hey, in order to scale, we're chopping things up into different systems, or different microservices or applications that handle different parts of what we do and that can kind of scale independently. And so we want to chop this up, but at the same time, it all has to come together and actually be richer in how it uses data to make the customer experience good. And so that was the challenge. Do more and do it better. The usual thing that the engineering team is asked to do.
Now, Jay got a little technical there. He was talking about a thing called microservices. And oddly, they weren't even called that until 2011, the first agreed upon reference to someone saying microservices. But okay, think about it. There's LinkedIn.com and it's running on a computer in some internet data center somewhere, right? There's software back there. There's a program. And you could imagine it's just like one really big hulking server with this one giant program that does everything that LinkedIn.com does. You could imagine that world, right?
I can, but what happens if there's a power outage?
Well, then it goes away.
Ooh.
Yeah. So you just make it so that it's real good and it doesn't break very often. That's not going to work, right? Everything breaks.
And power outages happen.
They absolutely happen. And you can have backups and everything. But part of what's going on here, just for a little color on this technical term Jay uses, is that at the time, and this is very avant-garde for LinkedIn to be thinking this in 2010, instead of this gigantic one huge monolithic program, big scary thing, it's just a bunch of smaller programs that kind of talk to each other. You can't tell that they're all there as a user of the site. It's just LinkedIn.com to you. What do you know? But really, the programmers are building lots of little programs that interact with each other. That's what he's talking about there. That's a fair description, you think?
I think so, but I think we can also take it a little bit further and say that these small programs are also distributed over thousands of smaller computers too, right?
Yeah, so these are, if you recall our episode where we talked about the migration from mainframes into cloud computing, we talked about servers and kind of these small, so yeah, you've got lots of these relatively small, cheap computers that you spread all of your work over. And we'll get into that more. Lots of hard things happen when you start doing that. And I asked Jay what kind of problems he and the team at LinkedIn were bumping into at the time that they had to solve.
I had been responsible for scaling a lot of the data systems that LinkedIn had. The database that served the main site, we built like a kind of fast key value store to make that faster and more scalable. I was part of the team that did some of the like social graph to figure out who you were connected to, and search systems to help you find people, and some of the back-end analytics for these data products. And I noticed that we had a lot of technology for storing data in different ways and looking it up, handling data at rest. But increasingly, as we had more of these systems and more applications, we were spending all our time kind of piping things in between. If somebody goes and updates their LinkedIn profile, how does that get into the search system? And how does it get into the social graph? And how does it get into the data warehouse? And that piping was getting to be harder and harder. And it was always breaking.
There's a lot going on there that might require some explanation. He said something about a fast key value store. We don't need to know what that is. We do need to know, this is just a fun note, he named that Project Voldemort.
Ooh, that's a great name.
Yeah, it's a great name. And that had, I think, a short life as a piece of infrastructure. But Rachel, can we go back in the last episode when we were talking about analytics? There are two kinds of databases in the world, right?
Yep.
There's the transactional ones and the analytical ones.
OLTP versus OLAP.
That's right. There the twain shall meet. If you missed that, if you need a refresher, the transactional ones are where we put the things that you need to keep track of. Orders, shipments, customers, like whatever those things are out in the world that change. When they change, you write them into that database.
And the analytical databases, the OLAP databases, are where you can ask that data questions. How many widgets did I sell in this particular area over this particular time?
Yes, which one sold the best when it was warm out? Whatever weird sorts of things you want. And just for technical reasons, they're not the same database. You have to make them separate because you can't make one that works well in both ways.
Because physics.
Honestly, and math and just logic. But in a social network, you could say like the connections I have to other people, my work history, those would be the transactional data. That's the state of the world out there. And the database changes, the transactional database changes when the world changes.
But when you want to ask questions of the world, and in terms of the work the database is doing, that looks very different from just updating the state of the world.
So yeah, Jay referred to the data warehouse, which would be the conventional place you'd go to ask those questions where you do, that's your OLAP database, your analytics database. And you're piping all this data around. But if you listen to him, it was even worse than that. He said something about search, right? There's a search bar and you want to go search for Rachel Pedreschi on LinkedIn. And that's this whole other place that data needs to get put in to be able to do searches well. That is a different kind of system.
I think I'm starting to understand now why you're talking about microservices. So each one of these different portions of the application, like search or like being able to see your friends network, all of these were a different service that got used.
Yes, with different places or different kind of specialized kinds of databases behind them to be able to store that data.
But what happens if I changed my job title?
Exactly.
I change it in the app, but then how do people search for that? Like if these microservices are all separate and micro, how do we make them all talk to each other?
In the good old days of the data warehouse, which we talked about in the last episode, that just got copied overnight. It was great, but that copying is brittle. After a short break, Jay will expand on that problem a bit further.
I'm Rachel Pedreschi.
And I'm Tim Berglund.
This is Keyboard and Quill. Let's get back to Jay Kreps on how moving so much data around was becoming a problem.
Our mandate was actually add more places this would go, more things that would be sophisticated and key off that change and be relevant to you. And that piping was getting to be harder. And it was always breaking. And it was always breaking in different ways for different systems because we would have some real-time pipes for applications that were very limited in their own way, but were fast. And then we would have these kind of big batch pipes that would shovel data off into the data warehouse at the end of the day. And they were limited in their own way. At least they were relatively scalable, even though they were slow. And then we would have other pipes that would handle. So everything was patched together. And anytime one of these things would break, everything downstream would also break. And it would just be a bit of a scavenger hunt to figure out what was ultimately the root cause, what was going on. And ultimately, when I stepped back, what I noticed that seemed really crazy to me was we had this big analytics infrastructure at the time that was a big data warehouse and Hadoop setup. And it was all oriented around this kind of batch processing. So we would shovel data into it at the end of the day. we would run these big processes that would compute a bunch of smart stuff about who you might be connected to or different aspects of the site. And then we would ship off those results in the morning and update things. And why did that seem crazy? First of all, we were running this at night, and it was like at night, California time. But this is like a global system that's happening all the time. And so what's magic about 12 p.m. midnight? Like, it didn't really make sense.
Back in the 80s and 90s, when we decided that it was a good idea to copy data at night between the one database and the other to make reporting and analytics work, was a much less globalized, much less internet-connected world.
Right. This was way before smartphones and even the internet.
And other forces of globalization. If you were a U.S. business, you did a lot of business in the U.S., nighttime is nighttime. Now there is no nighttime.
The sun never sets on the internet empire.
No, it doesn't. Back to Jay.
Secondly, it was just really hard to plug this back into the kind of user or customer experience. Like, by the time you have the results, that user's gone. They've moved on to the next thing. And so you don't have it when you need it. Hopefully they come back the next day or something and things are more relevant, but it just wasn't when you needed it. And so that combination seemed really odd. And this whole idea that you would run these kind of big batch processes at the end of the day, it just seemed almost like something out of the mainframe era. Like the tape drives would wind back and play forward some punch card reader. And so even though it was very scalable, it just seemed like a bit of a relic. And the idea was like, hey, if data is being created continuously as people use the site and do things, shouldn't we be able to get it around and react to it and build applications that act on it as that happens? Like, why does it take a day? What's going on? And that was the question. And then, of course, there's a long process to figure out the answer. And we took lots of turns. We built some systems trying to hack together pieces of existing technology and see if that would get it done. And it really didn't.
We've seen this over and over again in all of our episodes. There's a problem, people are trying to solve it, and we come up with various bad or at least incomplete solutions before we found the one that at least history says wins.
And as we understood the problem a little bit better, we really realized that kind of representing each of the things happening as a kind of stream of data, like all the changes to profiles, you could think of that as a kind of a river of data, what's happening that's just kind of always flowing. There's more changes happening continuously, and it doesn't stop. It's not like you come to the end of the table or the end of the file. It just keeps going on as new updates occur. If you had that as a fundamental abstraction, then all the applications and data systems that needed to act or react in some way could plug into that, tap into that river, and do whatever they needed to do as the data flowed to them. And this was one of the important things. You could do that in a way that was fast, but was also reliable, had strong guarantees for the delivery of data and the correctness of results. And you could do it in a way that was scalable, that you could grow horizontally to any size. And those were the characteristics that had held us back in all these other areas where we had different approaches which kind of would check one of those boxes, but nothing that did it all.
Let's jump in there again. Jay said grow horizontally, and that might not be clear. He means a thing that had recently become fashionable in technology to design systems. We hinted at this before, so you could run them not on one really big, giant, expensive server, but you'd split the problem up and run it on lots of small, cheap servers.
It was kind of like the same concept of having a monolithic application and then microservices.
Exactly. That is another example of that. People were doing that with basically databases at the same time. The systems that store data, or systems in this case that organize streams of data.
And they were doing this not just because it was easier to manage, but it also allowed applications themselves to become more resilient and easier to scale. I think we all remember, or at least people of a certain age, when the internet was a new thing and websites couldn't keep up with the demand. You would have a little spinning hourglass or a little spinning globe because the underlying systems couldn't handle the load because something had become really popular.
We're still in 2010 here in Sunnyvale with Jay. A few years earlier, the very early days of Twitter, maybe still in 2010, Twitter would go down all the time. You had the fail whale.
Oh, right. I remember that.
Started to make it into pop culture a little bit, and then there was some re-architecture, and suddenly Twitter worked better, and the fail whale just kind of died.
And a lot of people don't realize what was driving the fact that these websites now were more resilient. They stayed up longer. They could handle scale. We could talk about Black Friday and the advent of Cyber Monday that we still to this day say, hey, is this website that's gone viral, is it going to be able to stay up through all this demand?
Right. The idea being that with this so-called growing horizontally, if you have more users, more demand, more business, you add more servers. And that requires the people developing these things to build them in such a way that you can scale them by adding more servers. And there's a very complex whole discipline behind that.
So let's see, we've broken up all of our applications into smaller pieces, and now we've broken up all of our servers into smaller pieces, and we've broken up all of our infrastructure into smaller pieces. Ooh, sounds really complex.
It's an incredibly complex problem. I guess by way of analogy, imagine you keep a diary and you write something in it every hour, just kind of an update. Your diary, you add it to the end of the diary, and somebody else has a copy of that diary, and you need to make sure that their copy stays up to date with your copy. What do you text them? Do you call them? How do you do that if it's on paper? That's kind of a pain. There's a lot of hard stuff you'd have to do.
And this is something that humans didn't really have to contend with up until this point.
Yeah, except for the Avignon papacy, but let's not talk about that. Okay.
Did you really have to do it? Did you have to get Avignon papacy somewhere in there?
I really wanted to. It's a good example of the split brain problem. But anyway, back to Jay. This whole approach to data plumbing, this water metaphor he's using, it worked.
And so in that sense, it became this central nervous system across the different parts of LinkedIn that would connect them all up and let them kind of act and react to what was happening, that would get the impulses of what were happening in this part of the organization over to this other part that needed to know about it.
Central nervous system, rivers, plumbing, these are all great metaphors. This concept was not easy for technology developers to grasp. You and I were in the business at the time, Rachel, and we knew how databases worked.
Right. We had this idea that we could put some piece of data and insert it into a database.
Right. And go back and get it later. Like, that was fine. Kafka was a little bit different, and it took some explaining. And I know this personally because I spent 4.5 years doing that, explaining Kafka to software developers. And why was it hard? Well, this wouldn't be Keyboard and Quill if we didn't put our time machine through its paces just a little bit harder. Jeff, I'm going to need you to take us to 500 BC, and if you could aim us at Ephesus in ancient Greece.
The emphasis is on Ephesus?
Emphasis is on Ephesus. Jeff, you got us to the right place, but technically, Ephesus was controlled by the Persian Empire in 500 BC, would be for about another 21 years, but, details.
Who is it controlled by now?
Oh, this would be Turkey.
Oh, okay.
Yeah, we're modern-day Turkey. Anyway, we're going to visit with a philosopher named Heraclitus.
I like philosophers.
Me too, and he is lumped into the category of Greek philosophers called the pre-Socratics. All of these hardworking people who came before Socrates, you're the guys who came before Socrates. That's all they get. It's a little rough. Anyway, some facts about Heraclitus. He's thought to have struggled with depression. He's sometimes called the weeping philosopher. And in Greek philosophy at this time, there was this showdown between what is really ultimate reality. Is it earth, fire, water,
Instagram, TikTok,
air, the quintessence? He was a fire guy. Okay, in terms of his metaphor,
so
everything
TikTok
is ultimately fire. And focused on the idea of change.
So Survivor versus Real Housewives of Beverly Hills?
Perfect. I think perfect. And as a fire guy, he focused on change a lot. That's good. If you think everything is ultimately really fire, well, fire's changing. You just look at it, right? So he is famous, all this background to say, he's famous for this quote,
"No one ever steps into the same river twice."
What he meant was if you go back and you step in it again, the river has changed. That's not the same water. It's not shaped the same way. And by the way, you've changed too. Now, maybe not that much, but you've changed a little since the last time you stepped in the river. So he really emphasized the changing of things.
That's really deep. Well, maybe the river wasn't that deep.
I was wondering.
But how does that relate to databases in 2010?
That's an excellent question, because we've seen databases struggling with this idea. Like, people's state is changing, the properties that make up me. Let's just say my address, okay? I happen to have moved several times in the last 3 years, so I make all these address changes, right? So my state is changing. So databases have to keep track of things changing. We've seen copying data from one system to another. Jay was talking about that. If things are changing, it's hard to manage. All right. So this change that Heraclitus is majoring on really is a problem for people dealing with data, like Jay was at LinkedIn. Now, there's one thing, though, here that doesn't change.
The actual fact that you stepped into that river.
The fact that you stepped into the river.
Or that you moved a lot. Or that your hair color changed.
Yes, all true. So Heraclitus was highlighting the centrality of change, which is a very thorny philosophical problem, and it's interesting that he also used the metaphor of a river, Jay did. But in emphasizing that, it just points out that there are these things that happen, and this is this subtle shift that Kafka is encouraging us to look at here, us as technology people. Why don't we think about things that happen instead of things that are first? And those things that happen we call events. And this new system they're building at LinkedIn is built to keep track of those streams of events.
And throughout history, we've been really good at documenting events, things that have happened. We mentioned a historian that was looking at Heraclitus as the philosopher. We have maps that are written into granite near the Pantheon in Rome. So as humans, we get events. We know how to write them down.
And historically, there's been ways of writing them down. They're not all durable, right? I mean, we didn't talk about the Library of Alexandria, but it had lots of scrolls in it, and they burned down. It's not like they're all things that last forever, but carving into stone, clay tablets with cuneiform, these are really durable ways of writing things. And a lot of these mechanisms we've had historically, we know about them now because they were durable things.
But what's different now, kind of like how water evaporates, digital events, you can't look at them. They're really just electronic ons and offs, right?
Yeah, they're ons and offs. How much do they weigh? How do you go look at them? The thing that stores them doesn't look like the thing that it does. So
and how do you decide what order they're in?
Yeah, there is something a little troubling about these. They're much more ephemeral now. We'll come back to that. There's another early mover and shaker in the world of Kafka that I talked to, my former coworker, Gwen Shapira. In this quote we're about to play, she's talking about logs. Now, logs are a thing that at this time programmers had used for a long time to keep track of what's going on in their programs. And it really is as simple as it sounds. You just a thing happens and you say, I'm going to write this thing down in the log to keep track of what just happened. And as a programmer, you take a step to emit some line to a log. You actually say, I want to write this to the log right now. And you could look back on those logs later on to get an idea of what your program did. Gwen here, just to set that up, is contrasting events with logs.
And I think events is the key here. And this takes us slightly into Kafka world. But you said that all this data went into logs, which is correct. But the insight is that those logs correlate to events. The user clicked, the user scrolled the page, the user left our website and never came back. All those are very important events that happen. And they are different from logs in the traditional error logging, as in we encountered a misconfiguration in the database, but it's just a warning and we moved on. And companies like Segment figured out that the important thing is not the log. The important thing is the events that happened. And they built an entire company just around how do we report those events when we don't have access to the log. You are JavaScript running in the customer's browser. You still want to know what he's scrolling, what he's clicking. You can have bits of JavaScript that call Segment and report those. Or Google Analytics, for that matter, now has very rich set of events. So the idea that it's not about the logs, it's about the events was really transformative as well.
After a short break, we'll keep talking about events. But first, let's fire up our GPUs and mine some Podcoin to pay the bills.
At the tone, please record your message.
Hi, this is Vivi from California. Keyboard and Quill is made possible by StarTree, host of Real-Time Analytics Summit, an annual conference that brings together professionals in the data space to discuss harnessing actionable insights from real-time data. Join us to learn, teach, connect, and have an amazing time with the best community in the user-facing real-time analytics world.
Register now at rtasummit.com. I'm Tim Berglund.
I'm Rachel Pedreschi.
This is Keyboard and Quill. Let's get back to talking about events. Now, to be fair, at this point in history, this is not the first time a programmer had ever sat down and thought, oh, something has happened in the world. I should write code to respond to that event. I got my start in the early 1990s as a firmware developer, writing software for embedded devices. That's like a thoroughly event-driven proposition, that whole part of the world. But as an organizational principle for the software behind a giant internet native social media site, this is huge. This is an entirely new idea for that in that world.
So when you're looking at events that are happening right now and you're trying to figure out how to respond to those events, you need to process them nearly immediately. Jay hinted at this earlier. The tradition of analytics up until this point was to gather up all your transactional data and process it in big batches overnight. You come into work in the morning and you have fresh new data from the day before, and you can say, yes, I think I will sell bread in St. Louis tomorrow.
As Tony Stark would say, that's how Dad did it, that's how America does it, and it worked out pretty well so far.
It was great.
Yeah.
But not so much when your site's down and you are getting tweeted at by the President of the United States wondering why they can't update their profile.
Right.
So there was a huge business need to be able to process events, and there was a tendency to want to do it right now.
Yeah, because it wasn't like instead of taking information about things that had happened and sort of putting it in a place over there that you'll come back to later to ask questions about, the whole idea with this event-focused view of the world is something happened, I need to figure it out right now. Make sense of it right now. Here's Gwen again on this idea.
Yeah, this is a really interesting thing because I think the Hadoop world had a massive blind spot around real-time processing. Like the entire idea is that you process data in those large, very efficient, but also very long batches. And then you store it somewhere efficient and you just pull out the data, but the data is pre-processed. And so no one there was really thinking about real-time processing, except let's clean up data in the pipeline. That was maybe okay, but that was about it. And then LinkedIn came with the idea that, hey, Samza, and actually you can do real processing, as in the kind that joins and aggregates and slices and dices and all that. And you can do it to the data while it's in the pipelines, which is still mind-blowing, I think, like just the audacity of the idea, because I don't think there were those small type of processing, but doing serious analytics on data while it's in flight was extremely audacious at the time. And I think there were several companies that were really pushing the limits of what you can show customers in real time. And I think because it was fundamentally new, it was not, let's be more economically efficient and unbundle some way of processing that existed for the last 25 years, but it's fundamentally a paradigm shift.
I'd like to make a note here that developers seem to have really great names for different things that they work on.
Samza.
Hadoop.
They're just so good.
Kafka.
Yeah.
And we're not talking about men turning into cockroaches here. It's interesting because this paradigm shift that Gwen was talking about really actually reflects in the paradigm shift that is happening in our lives at this point, right?
Yeah. You mean the right nowness of our increasingly ubiquitous smartphones.
And our quickening pace of life.
Yes. Okay. So, those phones are always on. You no longer go and sit down at a computer at home to quote unquote go online. That's language people used 20 years ago, maybe in 2000, 2004, but it doesn't make sense at this point in history where we are in 2010. We're always online. Notifications are always happening. The computer in my pocket, it wiggles when it needs me.
You expect that the apps that you engage with on your smartphone are going to be updated in real time, have information in real time. You as a consumer can change between different apps if one of them isn't performing or doesn't give you the right prices. All of this is happening right now.
Yeah, and as this is happening, it's putting older businesses on notice. Businesses created in the internet era, well, the entirety of their life and all of their systems and for us as external users, our interface to them was through the web or, increasingly, smartphone apps. And it was completely natural for them to do that because they started from zero with the goal of making a website. But what about older businesses like airlines, banks, utilities, traditional retailers who are trying to build an online presence? They had all kinds of legacy systems, some of them dating back to the client-server era, some of them dating back to the mainframe era.
And you know what really at the end of the day drove the change for a lot of these older businesses?
What's that?
A really small virus that ended up causing so much devastation and death around the world, but also made some fundamental changes on how we live our lives.
Yeah, so Jeff, let's not go back to 2020. Let's stay where we are. I don't want to relive that.
I do not want to wear a mask again.
No, I'm good. But apart from, the social impact, the human tragedy, the stress and all the things that it brought in the world, the changes it made to the way companies' technology worked. I mean, buy online, but come do this drive-by pickup thing at the curb. They didn't have stuff built to do that.
Right, they had to make huge changes to their software, their internal systems, their infrastructure. And these were the ones that had created these giant monoliths 20 plus years before using the technology that was state of the art at the time.
Yes.
But they were slower to change. Newer companies had broken up the giant applications of their past into smaller pieces.
That's those microservices Jay was talking about.
And those companies that adapted tended to come out on top.
Yeah, so all of this stuff that the stage was being set for here, the pandemic accelerated it tremendously. But let's go back to where we were. At this point, we're probably in the mid-2010s. Let's talk about the demand that all this created for this new infrastructure called Kafka.
Now, not just how do I store data for one app, but how does it flow between all the things that I have? And I think that was very much driven by the rise of kind of consumer tech interfaces that were just much richer and smarter in how they worked. And that suddenly made it so that a lot of things that we were just used to tolerating from, the companies and products we worked with, it just kind of became intolerable. Like it was not good. It was not a good customer experience. And I think at the same time, the rise of mobile meant that you had a computer on you all the time. You were interacting with the kind of companies and products that you used digitally the most. And so instead of I remember back when the web got started, it was this kind of fun hack that a company would have a website. It was kind of this thing that was just not important. And of course, it looked very funky and didn't do very much. And so you can imagine, this transition, I think, happened in a lot of different organizations. If you think about how did you use your bank, that maybe that was primarily going to a branch or ATM, out in the world. And then over time, that becomes primarily digital with kind of a fallback to in-person, right? And so the importance of that as an excellent customer experience, it goes from how friendly are the people and how nice is the building that, your branch is in and how convenient is that location. That would be a good customer experience. At one point in time, that would be the predominant thing. To suddenly, that's pretty rare. Honestly, it doesn't really matter how great the building is, because most of the time it's a bit of a failure if you have to go into the bank. And suddenly this digital interaction being very complete and slick and easy to figure out and use becomes the most important thing. And I think that drives suddenly these systems in companies that were able to stand alone and be individual, they have to all come together. To your customer, a company is one thing, right? It's not 27 individual applications that don't talk to each other. It's just your bank or whatever it is. And so that pressure suddenly became very acute, and the comparison to these consumer companies that were good at it, I think, became very stark. And I think a lot of the more mainstream organizations became worried about that and really upped their game. And of course, a lot of tech competitors tried to go after that, and there's a rise of a whole wave of startups around it. So I think that was one big kind of macro trend. It's a bit subtle.
Early on in this, we had a water metaphor. Kafka is this new way of moving data around for purposes of understanding what has gone on and keeping things connected. Instead of putting all your data in one place, then copying it overnight to another place, Kafka is just this river of data. I traditionally use a slightly different metaphor. Your home has plumbing in it.
Alas, I do, unfortunately.
Maybe, dear listener, you just learned that the things behind your favorite app and site and all that have Kafka in them. But it's similar in that unless you're a plumber, you don't want to touch plumbing.
No,
you want to touch the fixture. It's a pretty bad day if you're working on plumbing. Now, there are certain kinds of plumbing, I have to say, I don't really mind so much. That's me.
Speak for yourself, Tim.
I am only speaking for myself. That's me. Typically, for most of us, we don't want to touch that. And Kafka kind of is that plumbing that connects all of those different systems, customer service and sales and order history and whatever all those things going on in that legacy business. It's kind of plumbing that keeps all that data flowing to where it needs to go. Makes your life better, but you don't even know it's there. Now, this particular piece of data infrastructure that a certain group of software developers and data architects and people know about has been at the center of a change in the way software is written. This podcast, this episode, really isn't about all the details of that. And it's hard to say whether Kafka is the cause of that or the effect or somewhere in between. It's always difficult to tease these things apart historically, right? What are the threads that contribute to the thing that you can observe? But we know that things are changing. You might remember when we talked about mainframes and what came next after mainframes. And PCs were this big thing, and this new paradigm replaced the mainframe, and it was this huge change in life, and it really was big. Of course, mainframes are still around, but Kafka really seems to be at the center of another such revolution that we'll have to see. Rachel, like you've said, it's hard to know whether you're in a revolution at the time of the revolution. You kind of need the judgment of history to know whether you're right. I think we're in one, and I think the best thing about that is we probably won't really know until after the end of my life, so I can just put my money on the table, and it's difficult to test.
So if you take yourself back to the early days of the steam engine changed absolutely everything that humans of that day were used to.
Yes.
But today, we don't really see steam engines very much. That technology has morphed into other things.
Right.
And even though Kafka and microservices are the architecture that is allowing our world to go the way that it is now, we don't know if this is going to be the future. We're standing here going, this is really cool, but in 20 years, in 100 years, what are people going to say? Because, to be honest, websites still go down. Apps still go down. There's a fragility to the data in our lives. It's no longer as literally concrete as it used to be in the past. How do we make our digital life as trustworthy as printed paper or carved on stone? These are the questions that we don't have answers to today.
I think that's a great way to look at it. We've got a little bit left in this journey. Let's see where we go next. Many thanks to Jay Kreps, co-founder and CEO of Confluent, and Gwen Shapira, co-founder of Nile. You can find links to their work in the show notes.
Also, thank you to Coastal Kites for the music you heard during our interlude. It's available on Spotify and Apple Music. Our show is produced by Peter Furia, Noelle Gallagher, and Tim Berglund. It was written by Tim Berglund
and Rachel Pedreschi. It was edited by Noelle Gallagher, David Fine, and Peter Furia. And our amazing original music and sound design were created by Jeff Kite of The Voids.
Keyboard and Quill is made possible by StarTree, hosts of the Real-Time Analytics Summit. Register now at rtasummit.com.
You can subscribe to Keyboard and Quill for free wherever you listen to podcasts, including Apple, Spotify, and YouTube. Please leave us a comment and a rating if you have a minute. And if you're a data professional, you should check out the Real-Time Analytics podcast, which we launched in early 2023. New episodes every Monday, link in the show notes. I'm Tim Berglund.
And I'm Rachel Pedreschi.
See you next time.